And we're live! Hello, hello. Hope everyone is having an absolutely fantastic day. For those of you that are in the States, hope you had a wonderful Thanksgiving. For those that aren't in the States, hello, No Corp. Friday stream! Oh, and I bet you'll love this. I got you guys a little present. You ready for this? You ready for this? Oh, look at that. Look at that capture. Straight from the scope. It's never going to be out of focus. Direct capture. I'm really excited about that. I'm really excited about that. Oh, hello, hello. Feels good. Feels good, man. I suppose I may as well talk about what we're going to do today. We've got an awesome stream prepared. And it's all about this. We got a little care package. Oh, never mind the coffee. Never mind the coffee. Got an Americano too. Running a little late this morning. Didn't get to drink it, but that's all right. That's all right. We got this awesome package from JLC PCB. And I was a little disappointed, to be honest. Right off the bat, I took this thing out of the bag and I was a little disappointed. Because this is what it came in. This in a cardboard box. No static control. I'm like, come on, guys. You're better than that. Well, apparently not. But at any rate, we're going to kick this off by inspecting the PCBs. Basically what we're doing is we got these from JLC PCB. These are from Project Seth. These are the 3D printer thermal runaway prevention PCBs. We're gonna get them unrolled here, inspect a couple of them close up, look at the components they got on the board and all that good stuff. See, we've got the logo on there, because why not? Just printed some specs on there, power consumption, those sorts of things. Version 1 Rev A, what could possibly go wrong? But we got a couple sweet videos coming up on the channel. I think they're still work in progress. I don't think they're up yet. But basically it's walking through the layout, some of the decisions that we made, how we got to this PCB. But yeah, welcome everyone. Welcome everyone. Yeah. Just gotta make enough room for all these boards. They're packed reasonably well. They did them like back to back on a no component side, so except for the fact they didn't use an ESD safe shipping mechanism. I mean, I'm alright with it. Alright, we'll get this out of here. So let's see. On the macro level, what do we got going on here? Well, we've got a bunch of boards. It's 3D printer stuff from the bench. Alright, let's zoom out a touch. We're a little close. We're a little close. So, I mean, honestly, these look pretty good. So, just looking for like consistency here, right? Well, if I could be a little more consistent in where I placed them. Let's see. Looks like the actual component placement, very repeatable on all their boards. Everything looks beautifully centered. Not seeing any tombstone components. Yeah, that's not half bad. That is not half bad. Wow. I'm pretty impressed. So, just to put this in context for y'all, there's probably 60, 70 components that were purchased, acquired, loaded into a pick and place machine, put on this board, and soldered in place. Okay? And all of that being done, I think the components and the assembly was like $2 a board, like basically component count or component cost. Like, I am floored. And they only have some components in their library, but they've got resistors, they've got capacitors, and that's like 90% of the volume of components we had to get on this board. So all things considered, that saved us a lot of time. That did not cost a lot of money. Let's take a look at the back side here. These all look pretty great. Looks like they added a couple tooling holes. I'm fine with that. I wish they would have asked, but they punched one where there is literally nothing. It is bare FR4, and they punched another one in a pretty empty spot too. Yeah, these look sweet. Well, we're gonna pick this one, and we're gonna call him Jerry. No, just kidding. We're gonna pick that one though. No particular reason. We'll set the rest of these off to the side. And we will do our final assembly. Now, I just realized a couple of the parts are off to the side. I'll have to grab those in a moment. But before we do, I want to get the microscope out. Let's zoom in on one of these. Zoom in on one of these. Let's take a look around this board. So, where do we start? Why not? We're going to start, I think we started with the top left in our schematic rundown. Theory of operation video, so why not start in the top left for our inspection. That leads us to plated through hole quality. Dang, that looks pretty good. Let's see if I can zoom in a little on this. Yeah, I know, right? I didn't even put rails on this design. They panelize it. They have their methods of reducing cost. And I think what it is they demand that everyone use green solder mask, and they demand that everyone use Hazel. So I'm guessing they're doing SMT assembly on like panels or quarter panels. Nope, there's no specific order number thing. Oh, you can specify order number. Yeah. Or like if you want it to be printed with something. Like ultimately, this isn't meant to be a turnkey manufacturing service for like production runs. I think it's meant more for rapid protos like this, where, I mean, I'm sure if I would have put in the comments like, ask me, they've been really good about actually doing what I put in the comments field. So if I say I want to approve the tooling holes, they'll probably ask, but they're probably operating under the assumption that I'd rather them just put their head down and build the thing rather than waste 2 days talking about tooling holes. They were probably just being independent to help me, but yeah. So I agree. So like when we did our run through, that's a good point, tooling holes and whatnot. So I added the fiducials for them, so that, you know, made one thing easier. But for the tooling holes and the rails, those could all go on rails if you were adding rails. I added rails when we were doing our full production run with SMT and through hole parts. In this particular instance, I didn't panelize it for them, and I let the board house panelize it. It's not too weird to do that. That's done. Like, it's kind of like they know their manufacturing process better than I do, so I'm not going to tell them how they need to assemble it. But they do give dimensions and stuff on their minimums, and I think what I did is I just kept the keep out like on this board edge, this LED. I just made sure that space, wow, my finger looks huge under a microscope. I made sure this space here was sufficient to meet their minimum keep out for placement, but maybe I didn't. Maybe I'm just losing it. They got the parts on there somehow though, so they might have, I don't know. They might have done like mouse bites and snapped off. It looks like there's a couple points here where they might have snapped it off after assembly. Maybe. I don't know. Either way, they got it done. I'll try to not be too critical. You can see you got a couple. Yeah, it's not so bad. I am seeing nothing that I don't like. This is a lead-free board, so you might be looking at some of the solder joints and thinking they look a little cold. It's just lead-free solder. It doesn't look as pretty as leaded. So that's why they look like that, but I'm pretty confident those will be good. So looking at what they have on this board, looking at what they've got here for us. Anyway, no court. I think you're down in Australia, right? So we just did Thanksgiving here. You're probably aware of it. It's kind of a thing that what would you call us, Yanks? I don't know. Something that we do here in the United States. What is your guys' excuse to like eat turkey? Do you have an equivalent holiday? Do you guys have like a reason just to make a bunch of turkey and eat it? Yeah, don't really do much turkey down there. Curious. But anyways, so we've got a couple of the parts here that I pulled off the stack. Got the comparators, which will need to get populated. Got the thermocouples. No turkey day? Australia Day. That sounds amazing. What do you guys do on Australia Day? I guess I can look it up, but if anything stands out, it's spectacular. I'm curious. Is that just like a general national holiday sort of thing? Where you're like celebrating like independence or something like that? Yeah, so just looking at our list of parts to populate, trying to find a pen. I think I do this every single stream. I always remember to do the printouts. I never remember to grab a pen. Found one. Alright, so looking at what we've got on the board here, just looking for one instance of these parts that's populated. C32, because being completely honest, I did this a long while ago. And I can't remember everything we had them populate. C24. It's bizarre that I'm not seeing C24 on my list. Oh, there it is. And then we need a C29. Yes, those are popped. C11, those are on. C8. C27, alright, those are good. All the caps are on the board. All the caps are on the board. By the way, how's the stream quality look? Does it look pretty good? I was monkeying around with stuff and could have maybe screwed up the networking, but it seems like it's getting through. Does it look about as good as always? Date is 1788, arrival of the first fleet, but generically just a public holiday. Yeah, fair enough. I guess you don't have to think about it too hard. If the government says, no one's going to work today, relax. Yeah, I'm not going to complain. I'm not going to say no. Got the LEDs on. Yeah, this one needs to get populated. Ferrite, bead, fuse, you gotta grab those. Connectors, yep, gotta populate all those. TE spade. Oh yeah, I need those. Relays. Those are screws. Yep. NPN. So we need that guy. Resistors. One R8, R2, R4. Looking pretty good so far. Just looking at the board, and they're all done already. That's excellent. I know there are a couple we need to populate by hand, though. 23 or 24. 21. So we got the 0 ohms on the board. Oh wow. Oh yeah, checklist. Yeah, I love it. 480p. Oh my. 480p. You know what? There's pixels in 480p just like there are in other resolutions. So that's perfectly good. Maybe I should zoom in a little more so you can read the checklist better. Oh, it is pretty small. It is pretty small. Yeah, I like the checklist. I started doing this because I don't know, it just helps me stay organized. Yeah, it goes a lot faster when all I've got to do is check the box, then I don't actually have to populate the parts. Man, I swear there's some resistors we got to put on this board, but I'm not. Oh wait, R23. Yes, okay, so we need to populate R23. Is that really it? R23 or R24? Dang. Yeah. Everything else is on the board. Except for those 2 oddball resistors that must have... They've got different classes of components at the JLC. I don't know why I'm talking about this so much. I'm just excited about it, to be honest. They've got different classes of components for their assembly service. There's some that they charge you like a fee. I'm assuming they're not the ones they have in their machines all the time. And if they don't keep the part loaded all the time, they charge you like 30-40 cents or something, maybe $1 per part to load it in. Ah, yes. No corp. Well, I'm glad you asked because I just started rambling about it. Yeah, so what it is you upload your whole BOM and you decide what you want them to populate or not. And so if it's one of those like already in the machine parts, it's just like 2 cents to put it on the board and whatever the component costs. If it's like one tier up where it's like they have it but it's not normally loaded in the machine, they charge you $1 or $2 for each of those components they've got to load in the machine, but they'll still populate for it. So you go line by line in your BOM and you check, yep, I want you to put this one on, this one on, this one on, this one on, and they don't do any through hole, only SMT. So you just go through the SMT parts in your BOM and you're picking like an LCSC alternate for the parts. They only pull from their own LCSC stock, and then there's like the really, really cheap ones and then the kind of cheap ones. So if you're putting on 100 parts, it's worth paying the $1 to like have them loaded in the machine. But in this case, I was gonna pay $1 for them to load an SMT reel to populate 2 parts. That'll take me like a minute. So I'm the one who told them what to populate. So if I were organized, I would just like know what they put on the board. They put everything on the board that I told them to put on the board. It's just a matter of you choose how much you want to spend and how much you want them to populate and all that. It's like 3904, 3906, LM7805. They've got all that stuff. They must have not had a surface mount variant that I want. Like, this regulator is very specific to our tolerance stack up, so I didn't want them to populate just any old 7805 there. Comparators they didn't have in their library, but yeah. Yep. Hopefully that answers the question. I liked it, to be honest, and it showed you like a cam preview of how they were gonna place, and yeah, it's solid. It's solid. It's got the switches, the LDO, thermocouple. All right, I'm gonna find my pile of parts that's got all this on it. By the way, a couple more people dropped in the stream. Welcome. Welcome. We can pop back to the microscope view and do another close-up if you guys like. Now, I'm not an expert, but I'm pretty sure all the parts are in this bag. It's amazing how quickly you forget minor details like that. Got our spade terminals. Yep. Oh my goodness, I was organized. I stuck all the parts we need in one bag. Proud of me. Sorry about the bag noise. Sorry about the bag noise. And if I'm lucky, cap, diode, what? Where's the thing of fuses? Oh, we'll figure that one out later. Fuses are easy. So, what was I saying? No idea. Completely distracted. Maybe just as a teaser, so y'all know where we're headed. Are these the right diodes? NV, nope. NV, nope. Those are also not the right diodes. Come on now, don't be like that. Oh. LED reference. All right, I'm looking for the NVRTS. NVRTS. There they are. Got them. We'll get these things on. The small little parts. 511K. Oh, what was I saying? Oh, I'm completely distracted. Oh, right. Yeah, what we're gonna do once we get this thing assembled. Should only take a few minutes, but hopefully you guys can read that. Basically what we're gonna do is, we were talking about the theory of operation last week? 2 weeks ago? That's all a blur. Anyways, we were talking about it, and there's some startup conditions that need to be met with regards to a couple of the voltage nets as we're powering on. The power on transient is really critical to this design powering on and latching on correctly. So we're just gonna get scope probe, get them on all those critical nets, and just see how it looks. We're just gonna tack on some wires and see what we see if the margin matches up. Hey JD, welcome. Hope you had a great Thanksgiving. And then we're gonna do a couple power cycles and see what happens. And then we're also gonna do some accuracy testing of the bed temperature trip. Just get thermocouples plugged into this thing, thermocouple in the DMM, and look to see what the DMM reads out when the monitor trips under different thresholds. Oh, also, we made an enclosure. So we can kind of do final assembly, crimps and whatnot. Get the thing put in here as well. Critical note, this has mains in it, so technically has to be a fireproof enclosure. Fun fact. Yeah, it's a box. I was super creative when I made this one, guys. Really flexed my brain. I went for a rectangular box. Yeah. To be honest, the creativity wasn't really my first goal. It was like, I need to make sure it's safe and I can make it look pretty later. So we added in like a half wall that'll go around the relays that keeps the main stuff over here. It's actually pretty nice. It's what I love about having a 3D printer, is you can make super custom enclosures with all your standoffs and perfectly sized holes so you can screw in your 2mm stuff and perfect cutouts for all your I/O and all your screws. It's nice. I'm spoiled now. I used to have to like drill holes in stuff to make an enclosure. Now I just model it in 30 minutes and hey, the printer spits it out for me. So yep, power entry modules and stuff. It's pretty cool. So we'll get it assembled for real. Yep. So that's where we're going. That's what we're doing today. I'm excited. Hope you guys are too. The ESD strap. Let's get this thing going. So, how many solder bridges do you think I'm going to make on those comparators before we get them on the board right? I'm guessing a lot. Alright. Tweezers. You know, I think it's only been, what, a week? Week and a half since our last stream? Feels like it's been a lot longer, though. I missed you guys last week. Which CAD CAM software? Never fixed my 3D printer. You made a fireproof box? Yeah, yep. So, yeah. I think it might depend on the regulatory environment. Like, it might depend on whether you're making like a home appliance versus like a medical device versus, you know, whatever. But the last guidance I remember hearing, that I'll be very specifically careful to not provide context for, but the last example I was working with, the UL guidance was it UL? CSA? I don't remember. The last guidance I remember hearing, yes, oh my goodness, yeah, JD. I've personally got the CR10. It's treated me well. It was one of the best budget printers a couple years ago when I got it. It's been a great couple years for 3D printers because exactly this. Like, this is such a detailed enclosure that would take so much time to do by hand. And just to be able to screw the thing together, it's awesome. But I'm using Fusion 360 right now. Fusion 360 is what I'm using. Free for hobbyists, free for people just getting into it. So, yeah, it's great that they do that. When you go on their website, they make it look like it's only free if you're a student. But if you look closer at their terms and conditions, it's as long as you're not using it professionally, it's free. I am a big fan of that mentality. Because it's like, I don't know, a lot of software, like if you try to get Cadence or Altium, something like that, yeah, it's going to cost you a lot of money. So it's cool that they're looking out for the little guys, hoping you learn. No Corp says, highly recommend 3D printer. Only problem with the cheap ones is the AC/DC supplies plus bad wirings. Oh yeah, yep. There's some fire problems that happen. Don't go too cheap with it. There's a lot of great reviews out there too. Check that out. I know, what is it? There's a couple guys like Angus, Maker's Muse, and now 3D Printing Nerd's good too. They make good stuff. A lot of great reviews. Angus goes a little off the wall sometimes when he finds some stuff he doesn't like. He's very particularly against bad wiring and connectors because it's a serious problem. So he's always on the hunt for that in his reviews, which is cool. But yeah. Yeah. So you can get some for, you know, $100, a couple $100 that are super useful. Once it's like I don't know, it just makes it, trying to figure out how I want to describe it, but it's like, you know, right now, if you don't have a 3D printer, you're like, oh, I want a little, you know, bracket, or yeah, I need to what is it, like a little hook for something light or a phone stand, it gives you another option. Because before 3D printing, your only option was, oh, guess I gotta go up to the store and buy it. But now if you're like, oh, that's a geometry I can model in 20 minutes, and I can make this 3D printable so it comes out in a hurry, well, now you might have just made it. Filament's isn't that expensive, really not that expensive to run, so like you can save a ton of money if you do little stuff like that. There's some people that 3D print little toys. Like if you got young kids, you can 3D print like little flying blade propeller things. It's a cool technology. It's gonna change the world. Well, in some ways it already has, but it's gonna keep changing the world. So, got a couple diodes. Thingiverse. Oh yeah. Yeah, that's true. That's true. Yeah, machine time adds up. Like, but like as far as human effort time, yeah, you just grab the thing off Thingiverse. That's where I got my my hot end mount for the what do I have? The Volcano hot end, the E3D Volcano. Yep, love that stuff. I think there's 4 of these diodes. Yeah. Yeah, so it might take 6 hours to print, but it's not like you're there, you know, standing there watching it. Hey, Dave. I was hoping you'd be able to make it. I loved your comment about the double line break, the line neutral switching. I was like, this is straight fire. I like these kind of comments where it's kind of diving in, making me think about things again. It's awesome. For those that didn't see it, it was on the, what was it on? It was on the video about the theory of operation, where you're like, if this relay fails open and this relay fails short, you might not actually open, or you might have line connected and not neutral. I was like, yeah. Yeah, that's real. Yeah. Yep. But this is the board. This is the project. 3D printer, thermal runaway prevention. You might notice we've got a couple spare boards. We'll see. Some of those might escape in our Etsy. What is it? The Boxo Junk? I don't know. That feels like Boxo Junk territory. Where it's like, we've got a bunch of extra PCBs. Some of them are even halfway assembled. By the way, let me know if you guys want me to do a close-up of the assembly again. I've got them at the ready, so we can dive in. But I'm happy y'all could make it. There we go. Can I zoom in a little more? No, that's all she's got. So not double pull, double throw relays. I've been eyeing the Boxo Junk. Yes. Yeah. No one's pulled the trigger yet, but that's okay. I figure this is one of those things where you throw it out there, and I'm just gauging to see what you guys are interested in. So, yep, basically just throwing out ideas. These are double pull, double throw relays. You'll notice there's a neutral switched and a neutral in and this other third contact. This third contact is where the power goes after it's tripped. So for example, if you wanted to put like 100,000 dB buzzer that pulls 5 amps and you can hear it for 3 miles, sure, why not? You can use one of those, and it comes out to these other 2 spade terminals. So, yep, they're double pull, double throw. Oh wait, double pull, single throw? Oh, I always get thrown off on this. There's one pull that you're flipping, and there's 2 throws. So single pull, double throw. Single pull, double throw. Yep. So one switches line, one switches neutral. Yep. Excellent stuff. Burning through our list of parts. These comparators might take a hot second, but we'll get there. Switching it elsewhere. Yes. Yes, yes. Yeah, so one of the, this configuration is sometimes required. Like, I know for some, like, automatic electric controls, it's required to switch both line and neutral. And I think the intention is that they want to prevent someone only switching hot, and then maybe, wire comes loose, comes in contact with the casement, and it's like neutral, so then it's like kind of live, where you're tying neutral and ground together in a place where you shouldn't be. I think that's what they're trying to prevent. But I figure, good practice. I already wanted to have redundant relays. I'd rather switch line and neutral so there's absolutely no power. It's like you unplug the thing if it's tripped, unless there's a fault. I don't know, just feels good. Makes me feel good at least. What do we got? How many comparators? 1, 2, 3, 4, 5, 6. 4, 5, 6. And we'll get our monitors ready as well. Thermocouple monitors. Yeah. Yep. I hope that picture, come back to what you said, No Corp. I hope that picture was enticing. I tried to capture the box of junk in all its glory, because it's like, we've been working on these projects for a little while. We've been just kind of accumulating some failures, some successes, some stuff that's now obsolete, some stuff that's just fun. And it's like, I don't know what to do with all this stuff. I have no idea what to do with all this stuff. So just, yeah. Okay. Let's do a close-up on this one. This one's gonna require a little skill, little tact. Interesting. Never seen switching neutrals. I don't know. If you crack open your oven, you might see it in there. You might see twice as many relays as you think they need to have. Or like a toaster oven might be subject to similar regulations. Something like that. Yeah. It's definitely a thing. Not sure if it's like in all markets all the time sort of thing. Oh goodness. This thing's a little tippy. I think. Yeah. Whew. I did a great job of putting that camera exactly where my fingers need to be. Let's see if I can put it somewhere a little better. There we go. Let's do it. I think I'm actually going to try to tin this first. I'm not going to try to use the hot air gun on this because I think I might lose my mind. But this is a pretty fine pitch part. We're going to need a little flux. Or should we try to use the hot air gun? I've tried to do this before where I tin it, come back with the hot air gun. but I usually don't like the result. I don't know. I'll grab the stuff. We'll try it. We've got the old computer side panel of glory. Get it tied into the ESD controlled stuff. 1 meg from ground, as it should be, not a hard tie to ground. Dope. Not quite the right spacing. By the way, if you're looking for a cheap way to store PCBs while you're working on them, I absolutely love this thing. Basically just anything magnetic, couple aluminum angle brackets, and a little bit of sheet metal riveted on there to give you a nice shelf. Works super well. Not an electrician sometimes. Don't want to switch neutral though. Problems with 3-phase? Yeah, could be. Could be. Okay. Now, I'm not sure if I can still get the microscope in there. Sorry about that. But it will be overall better. I don't want to cook these things too bad. That's what I'm trying to avoid. And it's like, when you make a short and then you've got to resolve it, you end up pumping a lot of heat into these parts. Just makes me a little nervous. Yeah, so one's looking pretty good. This one's got a little too much solder. There we go. Okay. Let's see what we can do. Switching neutrals and AC mains is a code violation. Yeah, I don't think they would do that like in a breaker panel. I was talking specifically within a device, like if you're switching power to a heating element, switching the power to both sides of it in the normal case. That's more what I was talking about. Not so much in like a breaker panel. That's a little out of my wheelhouse. Can't really speak to that. Yeah, so maybe that's something that, well, I suppose that is configurable here, because if you don't like the way that it's switching, they're just two independent relay contacts. There's no reason why you couldn't put them in series. So, yeah, take that for what it is. Not that the right solution is just, circumventing the design or whatever, but it'd work just as fine if you put both the relays in series versus one for one and one for the other. Alright, got her positioned. And we get her to flow. Let's see. That one looks great. Woo-wee. It's a little toasty, not quite there. Okay. I see one short I've got to resolve. And it's my own darn fault. It was there before I even started the reflow. And I'll come in and do a little inspection. See how she turned out. There we go. Okay. Microscope. Look at that. It's a little light on the solder, but I think she's good. Let's get a shallower angle. Yeah, look at that. Nice fillets on the toe there. It's not so bad. Let's check the other side. Am I getting the hang of this? That almost looks like I'm getting the hang of this. You absolutely spotted that. These are Harbor Freight magnets. Wow. You eyeballed that from a mile away. For those not stateside, yeah, Harbor Freight's like, what is it? Power something? No, Cambodian Tire. What is it? Something. Oh goodness, I can't remember. There's a similar thing. It's basically cheap tools, cheap tool store. Look at that. Yeah, those look good. I'll take them. I'll take them. Alright, so basically going to do the same thing, only different. With the LM7805, going to get some solder loaded up here. Should we do it with the comparators? Let's just do it with the 3 terminal side, because I really struggle with that on these. I struggle with not shorting the 3 terminals together. This is a SOT 23.5, so it's like one of those parts that's usually pretty easy. It just gets a little messy for me sometimes. There's 1, 2, 3. Must have had to splice the solder. One, 2, 3, 4, 5. Where's number 6? Come on now. Or did I miscount? No, didn't miscount. It's hiding. 1, 2, 3, 4, 5, 6. Nope, got them all. There we go. Yeah, this jig was definitely a case of reduce, reuse, recycle, where it's like I actually bought a PCB mount thing, and it's got the little plastic nubbins on the side, and like you can spin it. But my problem is that the whole jig like spins when you've got a board in it and you apply any pressure. It's like just not a fan. I wanted something with a little more rigidity. So that's where the idea for this whole jig came from. It was basically I like the idea of holding a PCB. I just don't want it to shake around when I'm trying to use it. Come on now. There we go. It's hard just to tin all 3 pads. No wonder I struggle to not make bridges. What do we got? Dave says, yes, looks good. I think that's about the soldering jig. Thanks, guys. Thanks, guys. I'm glad you like it. Yeah. Yeah, we used this a lot when we were making the Plant Light Project PCBs. You'll notice there's still some remnants of those LEDs. That's what reminded me. Because we soldered a bunch of really particularly nasty... Well, here, let me show you. Soldered a bunch of these particularly nasty LEDs. Carefully. Almost. There they are. So it's these little 3-pin jobbies. And getting these to flow right without warping the PCB, that was a pretty big challenge. So, yeah, that was the struggle. That was the struggle. Got a lot of hours on this jig. Alright, let's get a couple more. Oh, yeah. Oh boy. It's getting blown away. It's getting blown away. Alright, there's one. Might need a little more flux on these. Yep. So I'm curious, guys. I'm really glad that you could all join me today, and I just want to know if the way that I announced this worked well for you, because I've been trying to use like a YouTube feature where basically I just punch the stream data in a couple days before, and it seems to be sending out notifications or something to let you guys know. Try to let you guys plan ahead so you know. No corp. I like your creativity. Computer tower side cover is very creative. Frugal building. Closest piece of steel equals old computer bits, optical drives. Yeah, I mean that's what it was. This was an old case side panel. It really is as simple as that. I just needed something that was rigid and magnets would stick to. And it's got these nice features on it. These nice like bent features that make it incredibly rigid. Incredibly rigid. Yeah. But I just want to make sure that I'm getting the word out in a way that works for you. If it's just random and y'all happen to be free today, that's totally cool too. But just curious if you're getting those notifications or not. Still pretty new to this whole thing. Because of it being your subs feed? Awesome. Cool. I'm glad it actually like takes it and works with that. They've been tweaking all sorts of things on the platform, which is nice to see them being creative, but it can be difficult to keep up with. So like, yeah. They used to be all about the tags, now they're phasing out the tags. It's like, alright, whatever you guys want to do. Oh no. Oh no. We're losing this one. Oh boy, off the pads. Off the rails. I think it's there. One more. Oh, maybe. Yeah, I think we got her. Oh no. Oh, had to go and bump it. Okay, looks good. Woo! Tested. Oh, cool. Interesting. Tested. By the way, welcome, Tested. Welcome. I hope things are great for you, even if you didn't get a turkey day yesterday. As good as it can be without a belly full of turkey. Interesting. Yep, we've got a fun prototype tested. That's why we are streaming. We've got one of our prototypes from JLC PCB. We had them do a lot of the SMT assembly for this particular prototype. Just giving them a try. Never used that before. I am a big fan of it, and I'll be an even bigger fan if we powered it on and all the component values are right. It's like, this service was super cheap. Like, it was an incredibly good value, assuming that it all works. But they just don't have all the parts we used in their library of available parts, so got a little bit of fixing to do. Alright, so now here's where I might go and hose it all up, because I see some of these joints and they look a little cold, or a little like they don't have quite enough solder on them, but then, you know, you go and you try to touch it up a little bit and you inevitably make a little solder bridge. We'll see. I'll just keep cleaning the tip, keep wiping the solder off. Hopefully we'll get there. Alright. Oh, this one I never even... I think we'll just take a little trip around the thing. Let's just do it with the microscope. That's typical regarding notification. I think we've had a few days notice. Oh, that's cool. Never seen that. Weird. I wonder if that's a region thing or like a preferences thing. Yeah. It notifies me. It's like, hey man, do you remember that you said you were gonna do this? Cause you start in 30 minutes. It's like, I mean, maybe some people I don't forget about you guys. I'm pretty careful to remember. So yeah, those are my giant blobs of solder from this side. That's the side we reflowed, and the one that I touched up also looks pretty good. Let's check out the guy next door. Yeah, I mean, it might work. What do you guys think? Do you like that? I don't know how I feel about it. It's not giving me the warm fuzzies. Oh goodness, I'm seeing the stream. I am real shaky today. Sorry about that. Oh, I just don't know, guys. I just don't know. I don't trust that. I want to touch that up a little bit. It's the pad on my left, hopefully your left too. That's the one that's giving me heartburn. Is it this one? No, this one. This one. Just want to give it a little bit more. Nailed it. Maybe I'll try this one. Try my luck. No. Oh, come on. I keep bumping the iron. Getting a big old ball of solder. There we go. Sure. Alright, number 3. That side looks great. What about the other side? That looks pretty good. That looks good enough. What do we got? Two more to take a look at. I got one that's a little weak on this pad too, or on this part too. What is it? This one? No, it's this one. Give her just a little bit more. Oof. There we go. There we go. That is way too much solder. That one looks good. That one looks great. Almost looks a little overexposed. Yeah. Yep. Looks like a pretty decent solder joint. This one looks a little strange. There we go. Okay. That ought to work. That ought to get the job done. Just a couple easy parts left. A couple transistors. One linear regulator. Fuse and a ferrite bead. Then around to the big through-hole parts. We need 2 transistors, because one of those is being replaced with a 0 ohm. I think you guys you think so? Really? And that middle pin's got a giant blob of solder on it. I'm gonna take some away. Maybe more heat. I'll refloat it or touch it up. It looks better now. Unless it was the one before that? U5? I don't know. I suppose we'll see. I'll do a quick continuity check. No, I think I see which one you're talking about. I think you're talking about this one. The middle pins are scary. The easiest ones to cause a short. Dope. Uh-huh. There's a massive short. See what I can do about that. Anything? Okay, it's close. It's close. Here we go. Oh my goodness. Alright, got it. Didn't even need to get out the solder wick. I think you were talking about this one. It's a little wet from all the flux, but looks much better now. Okay. What was I doing? Right, these transistors. These are easy enough to get on there. You got Q5, Q4. Yes, yes. These are some tiny little SOT23 PFETs. I don't know what your personal opinions are. I'd be curious to see it in the chat. I'd be curious to see your opinions on this. I personally am a huge fan of PNP and PMOS transistors. And I think it might just be because it took me a long time to figure it out. And like once it clicked, I was like, oh, it's just exactly the same. But I got kind of stuck on N-channel logic. But it's like, man, PNP current sources, like, oh man, there's just something about it that I really like. Oh, did you learn to that splice? Makes your thin solder a little bit less thin. So yeah, what's your thoughts on PNP and PMOS? Do you like it? Do you hate it? Do you think it's confusing? Let's hear it. Let's hear it in the comments. Alright. So I need some oddball resistors. We've got a new tray color. Wait, what? Apparently I didn't load in all the parts. As long as we're here and we got the ferrite bead. That's how I'm doing the oddball parts, just labeling all the tubes with the part number and a summary on the top. Some like ferrite beads, PTCs, all that kind of stuff. So I want to get them all loaded in the parts rack. Oh, transistors. Yeah, JD. Yep. So PNP versus P channel. It's basically what it is. Like, you know, a lot of people use NMOS devices as a low side switch. So like you're switching a device to ground to turn it on. Another option is you can use a PNP or a PMOS device where instead of, you know, tying the base to a positive voltage, you pull the base down to a relatively negative voltage. So you can do high side switching with well, oh my goodness, my tweezers are a little magnetic. I need a demagnetizer. So you can use a PMOS device to, or a PFET, sorry, a PMOS or a PNP transistor to do high side switching instead of low side switching, which is sometimes advantageous, like when you want to have a common ground for a circuit. But I mean, there are trade-offs between the two, like PFETs tend to have a higher RDS on, things like that. But assuming you can find a suitable PFET or NFET for your application, what's your thoughts? Yeah, your opinions. So I've met some people that are very opposed to like PFET devices, where they would rather use like 10 N-channel transistors to avoid using a single P channel. Yeah, something like that, right? So you can use a PFET with an N-channel NPN bipolar transistor. Do it the other way around. In this case, we've got an NPN transistor driving a PFET to switch the relays. That's what we went for. And I cannot find my 0 ohm resistors. Oh, there they are. Yeah. Awesome. Yeah, I personally fall in the camp of use it when it's the right tool for the job. So like, I'll typically make whatever decision results in having the smallest amount of transistors doing the job. So I'm not too particular about one versus the other, it's just a tool in a toolbox. So what you're seeing right here is a workaround for the whole incorrect logic bug. When I was making this, I forgot that the relay is normally on, and so when the fault trips, it turns off our DC output, which isn't really the intent. Yep, agreed. I think I mentioned that about the RDS on PFETs. Yeah, I think it's like 65 milliohms or something for this part, this application. Yeah, but we got her down. We have our temperature monitors soldered down. We have our comparators. We've got all of our transistors on. Did the little mod. Yeah? Oh, dang it. Fuse. PTC fuse. One more. One more. Huh. And I remembered setting these aside, which is always dangerous. Whenever I set a part aside, I feel like I lose it. In this case, that might be the same story as usual. Yeah. Green LED, red LED, PNP transistor, connectors. Diodes. Transistors. It's in my oddball parts, connectors, inductors. Oh my goodness. We might need to bypass the fuse. Well, it couldn't have gone far. I just had it here. That's just bizarre. Sorry, guys. Thanks. I like hearing other people's wisdom and opinions. Good stuff. Yeah. Yeah. Me too. That is really bothering me. So I had the 4 different PTC fuses that we're using across the UPS. And I had them in a pile of approximately 4 anti-static bags. Indeed. And they stand out like a sore thumb in the shop because they're not the resealable type. They are the one-time hermetically sealed nonsense with the moisture bag. Alright. Wonder if I can fit this Nope. Alright, we'll just jumper it for right now. We'll jumper it for right now to get us going. Unless they happen to be... No. They're not in any of the racks. Yeah, I know. Well, I don't know where it is, but I guarantee it'll be in the last place I look. Is anyone like that? Has anyone used that before? Yeah. Unfortunately, the nearest flat surface is the one that I'm working on. Wait a minute. I cleaned the shop. I cleaned the shop. One more hope. One more hope. Nope, wasn't there. Wasn't in my pile of junk from when I cleaned up. Nah, it's gone forever. That's what DigiKey's for, right? Get some new ones. We'll see if I can make an 0603 fit on a, what is that, 1206? 2512? Oh, not a chance. Not a chance of making that fit. Oh my goodness. What a beauty. Oh yeah. That's art. That's art if I've ever seen it. Oh yes. Beautiful. OCP on bench supply? Overcurrent protected bench supply? Oh yeah. Yep. Yeah, this isn't in the mains path. DC, starting with the other DC fuses. Let's place you look, yeah. Jumper. Just use there's a, well, it will blow, just not quite at the same voltage level. Or the same current level. It'll probably blow at, I don't know, 3 amps, 4 amps, 5 amps, 10? I don't know, it's rated for 2. Oh my goodness. How am I forgetting the LDO? I forgot the LDO. Staring at the board. Oh yeah, that looks fine. Missing a massive component right in the middle of the board. Probably should put that on first. Whatevs. Whatever. We'll get it done. So. Time for the part that dissipates the most power in the whole design. Yep. Actually, it's probably the relays. The relays are pretty power hungry. They pull, I think, 30 milliamps at 12 volts. They're the awesome Panasonic industrial grade 10 millimeters of internal creepage and clearance nonsense there. One of the best you can get for this kind of application. We're only switching 120, but I figured, hey, may as well pick a part suitable for 240 just in case one of these happens to slip out of my fingers and happens to make it across an ocean. Open fuse, blown fuse. Okay. That's a couple parts. Got the switches that set our temperature. Got some of these spade terminals. Need side cutters. There. Woo! It's got some bite to them. I really only need 4 of them. Yeah. Because I'm going to use the 0.1 inch header to tap off fan power. I'm going to clip these even on both sides, or flush, or whatever you want to call it. Oh, by the way, I goofed up again. So my footprint's slightly too wide for these. Dope. So we can only leave one of the legs on. Yep. The whole fit is like perfect. It's a nice snug fit. Kind of keeps the thing behaving. But yeah. Let's see, a couple comments there. I'll get to those in just a second. There we go. Let those fit in. Alright, switches. What do we got? I guess that depends on whether you end up with glass or ceramic in your face. But yes, less ambiguous. Yeah, agreed. Switch is sealed. These? Nope. They are wide open. Wide open. Yeah, the I think I released the schematic for this, right? Pretty sure you guys have the schematic. If you don't, I goofed up. But yeah, so if the switch fails in a an open state, that'll trip the monitor. It'll trip the threshold. Or yeah, it'll basically set the threshold to 0 degrees Celsius, which I don't know about your 3D printer. Mine runs a little hotter than that. Alright. So you got the spade terminals in. Switch is in position. What I was trying to say with that is that, yeah, maybe it'd be better if they were sealed or something, but it's not going to cause like a catastrophic or an unsafe situation. It'd just be a little inconvenient. We didn't pick anything spectacular for these. They're just regular switches. Yep, might be hard to tell, but I was trying to manage cost on this design. Prevent, adding in things that weren't really needed, but actually adding in what was needed. I think that falls into the nice to have, and it's like, you can always sub out a switch. I feel like the footprint's gonna be pretty standard. It's just basically 0.1 inch spaced terminal. So you could even put in a connector if you really wanted. You can do all sorts of things. Okay. Yeah, the previous video, not in the description. Sorry about that. This was in the theory of operation video. Yeah. Try to copy that over. Must have missed that. Yeah. Well, I guess, it's been a while since we've talked about the UPS project. Do you guys want an update on where that is? Would you enjoy hearing a little bit about that? It's a little off topic in the sense that, this hold tolerance is a little tighter than the last one I installed. Weird, maybe the lead's a little wider? Looks like the lead's a little wider. Strange. Yeah, because there's been some exciting stuff going on with that project. In the general sense, there hasn't been a whole lot. Well, like I said, I was doing basically the same stuff we're talking about here, right? Tolerance stack-ups, doing more in-depth design analysis, those sorts of things. JD says, go for it. Alright, I'll go for it. Yeah, these are the Panasonic relays. We got ALZ12F12. Good relays. I like these a lot. They're a little spendy, but they are fantastic. Okay. So the UPS project, basically we've just been finishing up the main board, which is kind of tricky because the main board is what digital design. Yeah, maybe. The tricky thing with using a micro is ensuring fault tolerance, because there are a lot of faults that can occur within a digital system that are kind of difficult to mitigate. And it's like, how can you verify, beyond a shadow of a doubt that the ADC of your micro is running? And how do you know that it's giving you a valid output? And even if you can verify that, how do you know that the microcontroller is able to properly evaluate the functioning of the ADC if the ADC is not working? Or is there some larger fault that's just making the whole micro lose its brains? And then how do you make sure that the micro is going to fail safe? And there's some ways you can try to design that in, but it's kind of weird. MO cost might be reduced if going for digital design, but then you have programming to deal with. AT-Tiny44 has built-in. Really? Whoa! I didn't realize there were AT-Tiny micros with little FPGAs built in. I like the AT-Tiny series. I like the AT-Tiny series a lot. I didn't even know they had. Huh. Yeah. So I agree in the sense that I could make a cheaper version that uses a micro. Like if you just run these inputs into like an Arduino board or an ATtiny, or it probably wouldn't even take that long to write the software for it. The tricky thing is when you try to keep the same mentality of fault tolerance and failing safe, and when you try to apply that to a micro, it's really hard to do that without adding 2 micros. Which maybe I could add 2 micros and it would still be okay. Maybe it would still be cheaper even with 2 microcontrollers in the design. But that's kind of where my head goes, is that I'd need a microcontroller to actually do the work, and then another microcontroller to independently do the same work and have them compare. Then again, I think EEVblog did a video on a 12-cent microcontroller. So if I can get a microcontroller as cheap as a comparator, maybe I could. Oh, programmable gain amplifier. Fault tolerance is the problem agreed, plus the whole coding, testing the code. Yeah, I'm pretty comfortable with software. More than most folks that like analog electronics, I guess. But that's kind of like saying that I'm the best artist if I'm in a room with people that can't draw. I'm just kidding. I'm just kidding. Oh yeah, UPS update. UPS update. Sorry. I was cracking an analog digital joke. I got distracted. Yeah, the UPS update. So I've been working on the main board. Thanks for keeping me on track. Working on the main board. And the tricky thing about that is exactly what we were just talking about. The software. And it's like, so I designed all the daughter cards, I designed the main board, and I made some strong assumptions about the I/O that I expected would be required, just based on the previous UPS, what information I expected we'd need to be communicating between the main board and the daughter cards. But then, I found a couple daughter cards. I was like, oh, I really should add a signal from here to there that communicates. Maybe I want to bring an analog signal back over and I only had digital, or maybe I wanted to bring back 2 digital signals, something like that. And I did a reevaluation of the isolation strategy, the creepers and clearance that I was implementing, and I actually found a couple pretty big goobers. Yeah, doing analog versus doing digital. Yeah. So ended up switching things up a little bit. I don't remember if we ever shared this, but the plan was to use PCIe, like 16x, like the really long 168-pin PCIe connectors, as a great way to build this like modular connectivity while keeping costs pretty low because it's a commercial off-the-shelf thing. The problem is that the pin-to-pin spacing is 1 millimeter. So even if we keep out 500 pins, you never really get creepage distance because it doesn't meet the minimum spacing for the requirement. So even though you've got, 1/10 of a millimeter, 2/10 of a millimeter, 5/10 of a millimeter that you're adding up every time you skip a pin, it doesn't count. It doesn't work that way. So what I did is I switched that up to, and I'm kind of on the fence about whether I like it or not, but this is what I did for now, is I switched that to 3 smaller PCIe connectors. So now you've got like an alignment issue where you've got to make sure your through holes are pretty tight. Yep, that's exactly where I went. So I actually went triple 8s with a gap, or triple 4s. I did triple 4s with a gap. And the reason why is because I've got to keep some millimeters of functional isolation between the high voltage bus and the other one, because that's got 500 volts DC applied across it. Yikes! And I really want this thing to work. So there's like 5 millimeters of creepage and clearance between those two. And then I've got like a 15 millimeter gap between the low voltage bus and the self. So it's basically the same idea, only different. And repin mapping 168 pins to triple 4s. Yeah, that took some time. So that was a big thing that happened, but I think it's very important for the safety of the design overall. and actually making the thing work in a way that makes sense. This is looking pretty good. We're just about done cleaning it up. So that was one big change that I think is really good. And then we picked a micro for that because then that mainboard micro has a lot of stuff going to it. So I was like, man, finding a micro that'll have this pin count's gonna be tricky, and then the peripheral count to match. Like, we've got 5 UARTs on there, we've got I2C, we've got SPI, we've got a bunch of ADC channels and a bunch of digital logic. Basically what we ended up doing is we're using the same microcontroller that's used on the Arduino Do. That's what I went for. So it's an ARM micro, and the reason why I'm using the Atmel SAM whatever, the one that's on the Arduino Do, is because I really want to leverage the Arduino libraries for this thing. Like, we're using a bunch of commodity off-the-shelf stuff. Like, the display that we're using has a library. The UARTs, obviously, very configurable. They basically set up all the peripherals so you don't need to spend a whole lot of time working on it. But if I decide I want that granular control, you can always fire up Atmel Studio, go nuts, dive in the datasheet, and get that granular control. So gonna hope to leverage that, and so I've been kind of vetting that implementation, making sure all the peripherals will work the way that we need them to, making sure it has enough pins, and it has exactly the right number of pins, to the point where I had to stretch our legs into some of the pins not mapped on the Arduino Do, but that are still connected, so we should be able to go into the registers, set up the pins the way we need to, and get it going. We are also, I'm not a fan of the codes in some of the third-party libraries. Yeah, that's the thing. I would never, the big issue with a lot of those libraries is that they halt the processor. Like, they basically use a delay statement, and they just halt every single line of code, and it's like, come on. Maybe I could pull the pins and sockets tested, maybe. But I don't know about you, but pulling 50 pins out of a PCIe connector 4 times to assemble a motherboard, that sounds like fun. That sounds like fun for someone else to do. But yeah, there was definitely a few trade-offs that I was thinking about with regards to what I'd prefer. That's just where we landed. That's where we ended up. One more component. I don't like manual operations. Me neither. I'd rather put down one component and solder it in. That's the biggest thing that I'm struggling with. I'm like, I really want to have JLC PCB assemble this because they will do it for so cheap, so fast. I love what they did. But if I want to use their assembly, the main board needs to be green. The main board needs to be green. I really want it to be black or red or blue or purple or any color but green. I might need to send them an email, see if they'll do something special for us. Might charge me a little more, but I might be willing to pay for that. Alright, so these are the sweet Type K Thermocouple connectors we got. They've got the correct spacing, so you can't plug it in backwards. Pretty secure. Pretty nice. Kind of expensive. But that's okay. Paint it black. Yeah. So we'll see what goes on that. But so the micro selection was also huge, getting that in the design. Oh, right, I didn't tell you the best part. So one of the things that I want is I want to make this thing have a lot of connectivity. So down the road, you know, if it's like, I want to have this thing automatically shut down computers. And I thought that having like a remote web interface portal might be kind of nice. Even if it's gross, right? Just be able to check on runtime remaining, voltage, frequency, things like that. See just what's going on, right? get push notifications when your power goes out, because that sounds awesome. And I wasn't sure if I wanted to implement a, like one of the SPI Ethernet Mac-Fi combos like they do on some of the Arduino shields. But turns out the Arduino Do Micro, right now, tested, right now the answer is no. Like if you select a different solder mask color, it says, sorry, we can't assemble this board. So it's like a hard no for them. It must be a critical element of how they keep the service so cheap, because they will not do the SMT assembly service if you need a color other than green. And that might be a you need to ask sort of thing, or that might be a hard no. Time will tell. So it's like, I think about it, it's like some of my options are, if they don't want to do special colors, I could go back to all PCB, I could try Seed Studio. There's a couple different folks that do similar things but different. So there are some other vendors that I can check out, but it's like once you find one that does good work for a fair price and doesn't try to charge you $600 after they quote it for $50, still salty about that. $150 to $600, still salty about that. You kind of, I don't know, I like to stick with them. I like people that do good work for a fair price. I don't recommend the SPI Mac, had big problems. Can recommend the ones which have TCP UDP built in. Can also recommend the ESP32 PCB way. Pricing is difficult. Yeah. SAM3, yes it does. That is what I was getting to. It has a designated RGMII interface. So all you got to do is throw down a PHY, and someone actually is working on a library for the Arduino Do, like an Arduino compatible library that will basically let you use the integrated Mac and just run with it. So I plopped down an implementation with a Meg Jack because it was easy, and hopefully we'll get to play with that. So the idea is, even if I don't use it right away, even if I don't write code for it right away, the option will be there to add it later. And that's kind of my point with the main board. It's like if I need to redo a daughter card, that's one thing, but I want to make sure I've left myself with the hooks in place so that I can change population options, not modulars, just population options, to drastically update the functionality of this thing. I might be able to come to terms with green. I might. For the daughter cards, absolutely not. I want to put this thing in like a tempered glass side panel case with like RGB up the wazoo. I want this thing to look ridiculous. That's the only way I can describe it. It's not even cool. I just want it to be, I want to light it up. I want to show it off. Because this has been a long time coming. This has been a long project. So I'll basically say, never do this. It's dangerous. And then I'll do it. At least for a little bit. See those thermocouple connectors up close? Oh yeah. I might need to use that camera and just hold it up there, because the microscope does not zoom out very far. It doesn't zoom out far enough for me to show you this whole connector. But I can still show you. Okay. So I'll just come up here, zoom. So, oh my goodness. Moving is hard. Yes. Focus, please. Manual focus. Manual focus. There we go. There it is. That's what we got. Oh, I'm drifting. So, yeah. It's pretty sweet. On the end, it's got like the typical thermocouple connectors. Yeah, I think we're ready to fire it up, test it out. Just gotta grab a power brick and get it plugged in. If you need a coffee break, that was a great time. because we'll be off to the races in just a moment. Rainbow Plasti Dip with RGB LEDs. Pretty much. I mean, maybe not Rainbow Plasti Dip, but the idea is to get, well, we've got the RGB fans. I've got 8 RGB fan headers. I imagine we can do some damage with those. 8 RGB fan headers. Yeah, I don't know. I'm just weird like that. I'm really... LEDs are just neat. Okay. Get cleaned up, get cleaned up. Okay. I suppose, yeah, getting started up with the doing a smoke test might be a good idea before we use like a off-the-shelf power brick. Get that thing set to 12 volts. What do we set to? 3.3. Get it up to 12. Current limit. Got her pretty low. Okay. Got one of the, we've been dropping some links to these. I was pretty happy with these little UL listed 12 volt 1 amp power bricks. Nothing too crazy, just power. That ran over. Oh, you know what? We need to get some bodge wires with test points factored in. I've got a designated wire kit that I use for that on occasion. Yeah. A lot of these already have solder on them from previous debug. Okay. So we need 2v5, bed. Don't need the relay drive, that's just for fun. In case we find some issues, need to dive in. But we do need a lot of these test points. Yeah, see the point where I get lost on that is the Plasti Dip. I'll do the LEDs. I'll do the LEDs, no problem. It's the Plasti Dip that gives me pause. If you guys can figure out the CTI of Plasti Dip, sure. The hot, yeah. A CTI is comparative tracking index, by the way. That's like a measure of how well voltage can creep along the surface. It's a critical piece of the puzzle for how much creep resistance you need. Okay. So we need 2v5. We need the bed. Oh. The bed. I'm not in the frame, am I? Don't. These are threshold in the comparator output. And we need same thing for the hot end channel. So that ought to work just fine. So now we got VBed, ThermBed, and we need OK Filt. There you are. OK Filt, 2V5, 5 volts. Using a color code here. Orange is for the bed, green is for ground. Wait, orange is for the bed, yellow is for the hot end. Red is for intermediate voltages. Yep, it works. Just trying to make it easy to remember what goes where. Yeah, that looks sufficiently harebrained. That is a rat's nest. That's awesome. Yep. Creeps and clearance is for, well, we were talking about the UPS, and the UPS does have high voltage on it, but creeps and clearance applies for everything. It's just usually neglectable for things that are like really low voltage, because it's like, if you're creeping 10 microamps from your 5-volt rail, you don't really care. But when you start getting up to hundreds of volts, yeah, just have to start thinking about that a little more. Mm-hmm. Five volts. And we're missing one. Okay, filled. Oh no, we got it. Got an extra wire. Yeah. Looks good to me. Yeah, let's do it. Sorry, I think I got distracted. Creeps and clearance is for everything. It's just usually neglectable for low voltage. Yep, absolutely. Yep, low voltage potentials in the UPS. Plastidip does sell liquid electrical tape. Not sure what the CTI would be. Yeah, not sure. It might be rated explicitly. Maybe not. Alright, who's ready to see this happen? Oh, looks awesome. Forgot we need thermocouples. Because that whole fault tolerance thing. Yep, no thermocouple installed. Reads as 1,000 degrees Celsius, and then the UPS decides that's a little too hot for its liking, and it turns off. So, you need to grab a couple thermocouples. we'll plug in the 1. Yep. No. Oh goodness, it's like a USB port. Never plug it in the right way the first time. There we go. Latched on. Perfect. So you can see it's latched on because when these two LEDs, as visible, no, let's see if I can. When those two LEDs are on, that means the relays are on. When that LED is on, that means the power's on. And when that LED is on, that means it's detecting an error. So if I unplug one of these, you see the error light trips. Now the error light is on. The relays have turned off. You know what? Let's see if I can. There. And then if we reset, need to turn off power, turn it back on. Oh, right. The fault is still present. If we power cycle, see it resets. If we unplug the other channel, we'd expect to see the same behavior. That one's tight. Oh my goodness. Ugh. There we go. Tripped. Plug it back in. Clicking on. Fault's resolved. Cool stuff. Yeah, pollution degree is important. I was assuming pollution degree 2. Pollution degree 2. That's what I was assuming. Yeah, one of the videos coming up is about how we implemented creepage and clearance. And man, that was a hard video to plan because it's like, I want to help you understand it, but if you just start spouting out numbers, like people will just hear the numbers and duplicate it. It's like human nature. I really don't want that to happen because if you just duplicate a creepage or clearance distance, man, that can get real nasty real fast. Like, that is not a place where you want to copy paste. For the curious, we are running at 0.07 amps. So we're pulling 70 milliamps, which is almost exactly 2 times the rated current of these relays. So the actual monitor circuit's pulling almost nothing. Probably could have gotten away with a Zener diode instead of an Leo. Only need a couple microamps of current. Just make everything 20 millimeters. Yeah, I know. That's what I should do. 20 millimeters of creepage from 5 volts to ground. Sure. Why not? Let's see if I can. I've got the scope monitor software here. I want to see if I can get all 4 channels on without monkeying with the stream. We get these all. What do we want? Like 2.5 volts per division. Got to use the keyboard, which is a dangerous proposition. Alright, so let's switch over. Whoop, that's not right. There it is. So here's what we've got coming from the scope. Obviously not a whole lot connected right now. Trying to figure out how to bump. Oh goodness, 500 volts, huh? That's not what I wanted. There we go. Okay. I think I've got this software figured out. I'm learning as we go. 2.5, 0, negative 2.5. There we go. So, oh, negative 5. Yeah, there we go. remote monitor software isn't so bad. Pretty sure you have. Oh, pretty sure you have creepage clearance for everything. Oh wait, there it is. More. Just make it 20 millimeters. Off subject. You're getting nasty weather out west, USA, and cold weather and snow. Not too much where I'm at. Weather's pretty good. Thanks for asking though. Appreciate you. Yeah, it's not so bad. It's not so bad. 5. So -10. Dope. Accidentally turned off channel 4. -15. I'll get these spaced out a little more. What? Oh. What am I doing? I'm doing something wrong. Okay, 7.5. -2.5. There it is. Nailed it. Alright, let's get this hooked up. Sorry about all that monkeying around. First time with the new software is always a little hairy. So I'm gonna get this off the probe test. Get it connected to our board. Channel 1 will be connected to 2v5. Channel 2 will be connected to VBed. So that is our threshold voltage. Channel 3 will be connected to the thermocouple. Channel 4 will be connected to the OK net. Critical net. Alright, let's make sure all of our channels are set up correctly. DC, 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 AC. Alright. That's pretty neat. Let's see if we can. What are we in for the horizontal scale? Let's do 10 milliseconds per division. And we will trigger on channel 4, which is that OK net rising edge trigger. We'll get the level set somewhere where we should catch the power on transient. Single shot capture. Power down. Let's see what this looks like. That's not right. That's not what my scope screen looks like at all. at all. Technical difficulties? Apparently it needs to be operated from the PC. I can do a single trigger here. The channel configuration worked. I just need to set the horizontal scale. There it is. Do 10 milliseconds per division. Yep. Single shot capture. Let's see if that aligns now. Oh goodness. That didn't trigger. Channel 4, slope, positive, edge. level. That is all correct. Scope. Oh no, we're out of sync. Look good from here, good T2. Yeah, we've got the web scope capture thing. I just wish it would work. Oh no. Oh no. I clicked the forbidden auto button. Oh, I didn't know what I was doing. Okay. Alright, let's see what we can do. So, I need to set my horizontal scale in this bizarro world interface. I'm seeing the vertical stuff. I am not seeing the horizontal stuff. $20 milliseconds per division. And do auto type edge channel 4 positive 3 volts. Oh, and I didn't check to make sure all my probes are in the right. Selectable probes are great, but that's a lot of rope to hang yourself with. One of them gets out of 10x mode. So channel 1 probe is in 10x mode. Channel 2. 10x mode. Channel 3. I've seen worse. So I looked into the driverless capture that you brought up last week, No Court, and unfortunately that was just images. It wasn't like a live feed. It's kind of unfortunate. Let's see if we can do the single capture now. Just make sure we're still in sync. So it looks like we're good. There, it drops down. So in theory, if our trigger's set up right, let's go down to 2 volts. Okay, seems as though trigger is working. Single. Hey, got it. Wondering whether you can operate this. Judy found the parts at NEC that talk about switching neutrals. I'm not sure. Switching only neutral probably isn't the best move, but yeah, to your point, if you're switching both, maybe that'd be all right. Again, yeah. So what are we seeing here? 2v5 is channel 1. I feel like we almost need to overlap all these because we're looking for margin between them. So let's do that. Let's zoom these in a little bit. we'll need to recapture. I don't know why I was spreading them all out. That quantization error. Delicious. I wish there was an apply to all button. So I didn't need to type in all this manually. Alright, so let's do single shot capture. There it is. So, what should we expect? What should we expect? Well, so channel 1 is 2v5, vbed is channel 2. So channel 1 needs to be greater than channel 2. And wow, right now if we look at that with cursors, oh goodness, I can't even begin to do that on the other one. So I'm just gonna do it manual on here. Let's do a picture in picture so you can kind of see what I'm doing. But yeah, you won't be able to see them on the capture. But I'll just pull the numbers out so you can still see it. Yeah, so with the cursors, we've got wow, that is a ton of margin actually. It looks like there is no glitch, because that's where we had the issues. It was with the glitch on the OKFiltNet, and maybe there's a little one. You can kind of see it off on the left on that trapezoidally waveform, but man, that looks pretty good. Basically, we're looking at about 2 volts of margin on one of our startup cases, and we are looking at, wow, at absolute worst, we're looking at about, yeah, I don't think we've got a marginal startup condition. I think we're good, because we've got about 2 volts of margin on both our startup conditions. Oh my goodness. Just curious what happens if we go into run mode. I want to see if we can capture the glitch when we're changing ranges. You can kind of see the level change. It just kind of does. Our capacitors do a great job of smoothing out that change. Yep. Yeah, so it looks like we're able to tweak our threshold no problem. Yeah, so we had 2 volts of margin on 2v5 to vbed, and we had 2.5 volts of margin on 2v5 versus OKFilt, so that's excellent. The only thing we need to check is vbed versus thermbed, and those are the two little guys, the 2 small signals that we have. And that's a lot harder to measure just because the noise is definitely a factor. But let's try scaling those 2 channels a little more. Let's do a 0.1 volt per division. Yeah, we're gonna need to rerun this. Single shot capture. That is disgusting. Thanks, JD. I'm glad you're liking it. I think this is a lot better than the camera, even if it's a little clunky and takes me a little longer. Yep, gotta hand it to Rigel. They did a pretty alright job. So you can see we got a fair bit of margin there. There's definitely a lot of noise coupling on. There's a lot of flying wires that leads to coupled in noise. And honestly, that could be coming from the power supply. Here, let me try doing that with our power brick. We're gonna do a hard power cycle. We're gonna plug in the brick, so we'll have some inrush current. That's all right. Single shot capture. Let's plug in the power brick. Let's see what happens. 3, 2, 1, go. Yep, that 5-volt rail sure did come on a lot faster. That's a lot of startup margin. Look at that blue trace, channel 4. Whoop! That's our capacitive voltage divider. Yeah, VGA, let's go. Yeah. That is one heck of a capacitor voltage divider. Oh, let's do a power cycle with the... So yeah, if you're plugging in the 12-volt power brick and not doing a soft start, this thing is going to turn on no matter what. There is gobs of startup margin. Doing the soft start through the power brick, that's still a lot faster than our lab supply. Cool. Oh, that gets me excited. It's nice seeing something work. That's almost ideal. So the simulation was a lot more conservative, or maybe it was that specific comparator isn't as good as the one that we actually selected for the application. But like the startup glitch rejection on these is incredible, because it's basically not touching that OK Felt net, or the OK Felt net. So I'm feeling excellent about that. We've got as much margin as we could have. Just pulling the cursors so I can give you a more calculated measurement. So our steady state margin is about 250 millivolts, and that's by design, right? The threshold needs to be pretty close because, well, this is comparing the output of our... This is comparing the output of the thermocouple monitor to the threshold that we're setting with the RC time constant. And the threshold that we're setting, let's see. So VBED is on channel 2. Channel 3, okay. So our thermocouple starts up real fast. Let's see if I can zoom in a little closer on that. Uh-huh. Uh-huh. Let's try capturing that again. Not quite. Didn't quite capture it. Need a little bit more. Yep, so you can see the RC on channel 3. Channel 4 has already reached, or sorry, channel 3 has already reached steady state while channel 2 is charging. So there should be a little glitch there, but I'm guessing what happens is the comparators lock themselves out until a valid voltage threshold is reached. I'm guessing that's what we're seeing here. So basically, it's as good as possible. Our threshold is setting that. So I have that set to the minimum temperature, which may be worse for some things, may be better for others. what I want to do is take a moment and set this to oh goodness, thinking and typing at the same time. Whoa. There it is. Single shot capture. We're gonna power cycle. And look at how our margins look when we have this set to the extreme maximum temperature. Still excellent. Yeah, this was one where the system's pretty simple, so we could do a pretty thorough analysis. When you do a pretty thorough analysis, things go pretty smoothly when you're doing bring up. So now you can see the thresholds are charging a little higher, thresholds are set higher. Don't mind that channel 2 is actually higher than channel 1. The scale's different. We're at 250 milli versus 1. So yeah, that all looks fine and good. Looks great. So we get more margin on the V-bed versus therm bed because, well, there's more margin there. We're at room temperature. So yeah, it's as good as possible, and we have at least 2.5 volts of margin on the other two thresholds. So yeah, that's like build 1 million of them and they'll all work. Territory, that looks great. So what we're gonna do is we're gonna swap around a couple of these scope probes. Yeah, a little bit of Sims, a little bit of MathCAD. Got the job done. So we're gonna hook this up to the same 2 channels. So if you've been following along and it's been making sense, it should still make sense. We're just looking at the higher, sorry about that, looking at the higher temperature ranges here. So now we're going from a 207 to a 393C instead of where we were before. I'm going to adjust the scale of those to 500 millivolts per division, just to make the scope capture look a little nicer. Gonna single shot and power cycle. Okay, what do we got? Well, thankfully, 2v5 or OK Filt starting up still looks excellent. That's the channel 4. Channel 3 looks great as well. That's our threshold charging up to yet a higher voltage, because now we're at 207. Actually, it's only 7 degrees higher than our previous threshold. And then yeah, 2v5 looks about the same. Let's go ahead and try this with the worst, I'll say worst case, but the DC power supply, the lab supply, since that was starting up more slowly. And it looks like still looks good, still looks great. Yeah, can't beat that. So our startup margin, that looks great. Looks absolutely excellent. But you know what it is? It's time to put our money where our mouth is. Let's do a couple power cycles. We'll see if I can count to 25. So I'm gonna unplug this, and I'm going to do 25 power cycles with the power brick, or with this connector. There's 1 success, 2 success, 3 success, 4 success, 5 successes, 6, 7, 8, 9, 10, 11. Yeah, automation is a great thing. Can save you a lot of trouble. I think that's 15, 16, 17, 18, 19, 20, 21, 1, 2, 3, 24, 25. Look at that. 25 out of 25. Not bad. That's what we would expect if there's really that much margin. So now we're going to do the same thing, just we're going to do it on the power brick side. So we got 1, 2, 3, 4. Sorry, that one, we'll do 4 again. That one came unplugged over here. 5, 6, 7. 9. I'd love to do them faster, but I gotta wait for the soft start to actually happen for it to discharge. I think that was 12. Cycle testing, man. Doesn't get more riveting than this. What was that Norcorp was saying about not liking to do things manually? Yeah. Sorry, I forget. I'm too busy doing things manually. Oh, what is that? Are we there yet? I think that's about 20. We'll do 5 more. I think you get the point, though. This is starting up reliably. Obviously, this is only one sample. You need to do this for much, much longer with many more. Like, we need tens or hundreds of these running for weeks, cycling across temperature. You know, get a relay switching these on and off. Alright, we'll call that 25. That feels good. That feels good. Okay, on to the next test. Want to check the accuracy of these things. So I'm going to grab a thermocouple for my DMM. We're going to test out these ranges. Yeah, there it is. No problemo. There's a. There we go. So I've got this plugged into the DMM. Gonna set it to Celsius degrees. And all we have to do is find a way to thermally couple these. I guess we'll start with the higher temperatures because, well, that's what we've got. I believe we've dropped links to these specific thermocouples. If you want to get them, they're just a 5-pack. They're pretty cheap, nothing too crazy. It's, yeah, they're not even really rated to go up to the highest temperatures that we're going to today, but and that never stopped us before. Why let it stop us now? A little bit of tape will go a long way. Just kind of keep these together. Keeping them close, like physically close, will help a lot. So now these thermocouples should be approximately the same temperature. And I'm going to use the hot air gun. Just right now we're evaluating 393. Oh my goodness, that's hot. Let's start at 207. I'm gonna set the hot air gun to like 220. Just to make sure we hedge our bets. So the airstream should be about 220 degrees. Let's see what these say. And actually, yeah, we don't need to see the scope. I can pull up the scope for another one. Whoa, tripped it. I think I was going too fast. Like the air was really hot. Alright. So let's do that a little slower. So that our DMM can actually like keep up. Should be looking for about 207. We're up at 150. It's about 187. I think that's within spec. I need this to be colder. Alright, let's see if we can do that a little more gently now with a lower temperature. We're at 150. 170. 180. Oh, 192. 192 is what I saw when it tripped. What about you guys? So 192 on 207. That is definitely within spec. Where's the calculator? 192 on 207. 192. That's 15 degrees of error. That is about 7%. 192. Considering we've got a 4% accurate voltage reference, that yeah, it's not too surprising. Let's go up a range. So that must mean our LDO is running a little low. So we've ranged up one. We should be at the 249 degree threshold. Sorry, 249. 249. Need to turn up the hot air gun. Got the air gun set to 230. This thing's running a little hot though, so I think it'll be. I think it'll get there. Come on, 249. Let's see it. All right. Looks like we're a little above this range. 250, 260. Oh, that's just not fair. I'm not able to get hot enough. This air gun, man. Bump it up 30 degrees and it doesn't move. Ooh, boy, that's getting hot. Wait a minute. I don't know why I was saying we were out of time. Okay, 260. 280. My goodness. This does not want to trip. Oh, it's already tripped. Oh my goodness, Ryan. Oh my goodness. Okay, now that I've got my brains about me, I didn't hear it click. Okay. Looked about right. Again, we gotta creep up on this because... Alright, watching carefully. Got up too fast. Okay. About 200. About 210. And that's pretty light. Let's see if I can turn this down a little bit. Yeah, right about 200. Well, that's about as accurate as we're gonna get. I was just hoping, 'cause that's not very accurate at all. That's alright. That's what we'll range up for. Should be 296. Well, we haven't tripped at 250. That's a good sign. Maybe one of my resistors is populated wrong. Wonder what I told him to populate for R8. Wonder if it's right. Okay. Increase temperature more. We should be up at 296 with this threshold. That's where I'd expect this to trip. I think that was about 250. But again, we were going up real fast, so it's hard to say. Creep up on 250 a little bit. See what we can do. 260 is what I saw that time. Highest range should be 393. $296. That's good. To bump up the heat again. Man, I really set that high range up there. That's gonna be tricky. How high does this thing even go? You can normally run around 325 for soldering. Can we get up to 400? I don't know, that's hot. $350? $370. Excellent. $370. We were coming up on that pretty slow. I believe $370. So what does that mean? What does that mean? Well, it means we're in pretty good shape. Let's test the other. Let's test the other range. So looking at the numbers here, we were at, what was that, 7% error. 200 of 249. That's pretty bad. That range was pretty out of whack. That smells like a math error to me. So that was almost 20% error. 296 minus 260, so I got 36. On 296, it's about 12% error. And then I don't know why I added an extra significant figure on this, but we got 23.7 degrees of error on 393, so that's about 6%. That's not too bad, because I think what I said is that we would expect the accuracy to be a decay towards 5.7%. 5.7% is our minimum error. So, yeah, that's not too bad. So the fact that up at 393 we're seeing 6%, that aligns with what I would expect. It's just a touch over 5.7. It's at 5.7 plus or minus 2 degrees. So, it's not bad. Let's check out the lower range. All we've got to do to switch over is, of course, take the other thermocouple. So this is all well and good. I hope you guys are enjoying this. Hope you guys are enjoying the testing that we're running through. Let me grab these signals on the scope so you can actually see what's happening electrically while we run. So we're on our lowest range. Let's do our highest range first. And what we're really looking at is, in this case, channel 2 versus channel 3. So I'll zoom in on those a little bit. And what we'll see is that purple channel is going to come creeping up on the blue one. Actually, I bet we can do picture-in-picture and show you all of it. Look at that. So now you can see the temperature and the scope. Great. Snap switch on the power line instead of unplugging too much. Yeah. I will certainly look into that. It's just not something we can do right now. Yep. Yeah, personally, I feel like we've got this great relay board. If only I were to hack it so that we could use it to power cycle the design itself. Wouldn't that be something? Okay. So our range should be set for 200 degrees Celsius. We've got the hot air gun set to 161. Let's see what we get. Oh, look at that. Oh, that's fun. You can just see it get closer and closer. Hard to watch everything at once. We're at 180. Oh, we've already tripped. Yeah, I kind of went up on that a little too fast. Okay, relays are on. Got the hot air gun set to 125. Oh, we are close. I think I need to bump up the temperature a little bit. We're at 180. This one might be super accurate. I'm loving what I'm seeing so far. 94. What was that, 97? Let's creep up on that a little more. Oh, 118. Wait a minute, that doesn't make any sense. I got a lower temperature that time than I did the time before. So we've seen at least 190. I think the little thermocouples we got have a shorter time constant than the one that came with the multimeter. Yeah, there's 90. Come on now. Yeah, so about 92. That's what I like to see. Huh. 192. That's almost exactly the same trip threshold as the other one. Yeah! Attached to heatsink, slow it all down. That's a great idea. And I've got a box of heat sinks. You guys are the best. Full of great ideas. There we go. This heat sink's kind of big. It's full of gap pads and stuff. It's alright. We can take that off. Here's what this is what I keep you guys around for. The great ideas. Just kidding. Alright. So let's just see if I can't kind of screw these both down to one spot under this heat sink. Alright, let's get all that scope stuff out of the way. Scooch that a little bit. Get this in frame. And that clamped down. I actually did something similar to install this on the printer. I got one of these thermocouples on there, and I ended up using one of the screws to the hot end, kind of clamped it in place. There you go. That ought to do it. Thanks, NoCorp. Hey, no surprise. Our heat sink's at room temperature. Let's see if I can do this without burning my hand. Oh, wait. Thermocouples came loose. Thermocouples on the run. This might be harder than it seems to get both these clamped down. And let's give it just a little tweak with the screwdriver. Alright, showing the dual view. Well, let's switch to the low range, actually. So we're down at the 76-degree trip. That's just a warm day. Yeah. I think depends on the thermal pad. Alright, so we're at 72, 73. Oh my goodness. Alright, I gotta be... it's hard. There's a bunch of fans running. It's hard to hear. So we're at the 76 degree. Listening carefully. Sorry, I'm very in the way. There we go. 100 degrees. Oh, 70. That's reasonable. There we go, 82. So maybe it's actually that low side resistor for the high temperature range on this one. Because there's that common resistor that could throw off a lot of those thresholds. Gonna get that power cycled. Oh, one of the test points ripped off. Surface mount test points, that never happens. So now we should be looking at 95 degrees. Starting to get a little toasty. Might need a something to stand that off the workbench. Have an old dead PCB somewhere? No, but I should find one. Hey, look. Solder sample from the Phase 1 UPS. What perfect timing. Protect the bench. See why I need black PCBs? They look so cool. So there's some phase change materials for thermal pads, to come back to your question, NoCorp. There's some thermal pads that are made to change phase, and those can get pretty toasty. Alright, we need this thing to get hot in a hurry. Alright, we're at 80. What are we expecting for this? 95? I'm pretty close. Fortunately, heat sinks start radiating more heat the hotter they get. I'm glad we didn't do this for the 400C. That would have taken forever. Alright, blasting it with 200. Getting close. What was that, 93? Oh my goodness, that was close. Let's do that again now that the heatsink's close to the right temperature. In the local area. Alright. Just creeping up on the last few degrees. That can't be right. 74. I think I'm getting an issue where the heat's like blowing, like it's going down, hitting the heatsink, blowing around and getting on the... Dave, have to go for dinner now? See you, Dave. Yeah. Thermometer's going great, I think. Whether thermometer, yeah, no problem. See you soon, Dave. $94, $95, 100, 102, 103, 115, 112. That's about where we tripped. Range up. So I should be looking at 139. Getting close. 125. 140. 150. 161. That's what I saw. How about you guys? So 161. And actually, I think that makes perfect sense. Since we'd expect this to be pretty much like a scalar. That's pretty smoking hot. I want to chat about this for a second. So basically, we expect this to be a scalar error. And what we saw is that we were a little bit above the threshold at 76. A little bit more off, a little bit more off, a little bit more off. Which makes sense, right? It's a percent error, and we're operating this circuit at one temperature. So the amount of error should be approximately constant. The fact that our higher range was all over the place means that there was probably either a math error or a component that was populated incorrectly. So if we take 82 minus 76.4, we get 5.6 degrees of error. That's about 7%. 115 minus 95.1, we're at 19.9. That's how many degrees of error there were. Divide that by 95.1. Yikes, 20% error? What is wrong with that second range? What is wrong with that second range? 139, 161, 22 degrees of error. Divide that by 139, we're at 15. 192, 200, 8 degrees of error. Divide that by 200. Huh. Wait, is that right? Yeah, look at that. That's 4% error. Did I figure some of this? Because that went from good to terrible to excellent. Yeah, those two middle ranges, 22 degrees. Huh. That's bizarre. That's bizarre. Alright, you're just gonna get the scope disconnected here. Get these leads kind of pulled off. Got this maze of wires. There we go. It's a pretty warm heatsink, eh? Just gonna grab these wires off. That is pretty interesting. What I want to do is probe around a little bit with the DMM. Do either of you have the schematic handy? I don't have it printed off, funny enough. Just want to do a spot check on those resistor values. I'm gonna have to do that offline, but That's alright. I'm wondering if the switch might be, I don't know, a little different than I'm expecting. Wonder if the switch is like shorting together a couple nodes that weren't designed to be shorted together on those two middle ranges. Getting this undone. That's a good idea with the heatsink. Thermal time constant. Slow them down. Became less important. Okay. Get this in ohms. We should be able to probe all the ranges that are not connected. So it looks like our... I'm just going to read these off and I can follow up later. So we got 30.1 kilo ohms for R2. R3 is 23.52 kilo ohms. Got 6. Oh, that's the range that's in circuit. R4 is 15.2 kilo ohms. What are these? Trending downward. And then we've got a 10 kilo ohm for the 200C range on R5. Looking on the other side of the circuit, R7 is measuring as 38. R8 is measuring as 30. R9 is measuring as 23.5, 23.6. R10, 15.4. And just to double check, our low side resistor, what are we getting here? 8K, but that is kind of in parallel with, yeah, we can't really probe that resistor. Can't really remove it from circuit. But, so I will have to follow up and see if that looks correct. I think we're just about done here, but let me know if you got some questions. I'll just start installing this thing in the case and take the last couple questions. But hope you guys enjoyed. I thought the stream went really well today. I don't know about you guys, but I'm feeling pretty good about how this temperature monitor is working. Rough order of magnitudes, things seem to be behaving as expected. Maybe not perfect, but certainly pretty good. Excited about what's happening on the UPS. Excited about what we accomplished here. I will certainly enjoy the peace of mind that comes from knowing that this thing is, you know, pretty much working. So, yeah. Just want to thank you all for joining the stream today. Keep an eye on the channel. We've got some exciting stuff coming up with the UPS project. Got a couple more videos to close out this series. Then we'll be back on the UPS. Forget exactly where. I think most of December will still be Project Seth, or the thermal runaway prevention. And we'll be switching gears again. There's a lot of work that needs to get done to finish up the UPS design, so not sure exactly where that'll fall. It's possible we'll take a little break and take a couple weeks off and just chill. Hey JD, glad you enjoyed the stream, JD. No corp, No questions at the moment? Oh my goodness. Yeah, you better get to sleep soon. Oh, 500. That is early. That's closer to when I'd wake up than when I'd go to bed. But, you know, everyone's on their own schedule. So, sounds great. Yeah. Cool. So got the power entry module installed. This guy just clips open. You put in a fuse in the holder and drop it in. Yeah, that looks pretty neat. And by the way, it is symmetrical. Don't worry. It's just not symmetrical until you finish putting the box together. And that would trigger me if that was just off center. Yeah. It's a pretty neat little enclosure. Yeah. We've got the one half that's got the wall, and the one half gets everything else. So this guy will just mount like so, with the mounting holes. And then hopefully, if I did my math right, yep, power connectors pretty much centered right in there. You can tweak the range switch through the whole range, but it's recessed so it won't be accidentally bumped. Sweet. Cool. There's only one more thing I need to test with this, and it's basically just start using it. And I want to calculate some metrics on false trips per hour, or per 1,000 hours, or whatever it ends up being, whatever metric ends up being most significant, to see what our false trip rate ends up being on this. Based on what I saw today, it seemed like it tripped when it should and didn't when it shouldn't. So, yeah. Hopefully it'll be some very small number of failures for some very large amount of hours. Well, I'm glad you guys enjoyed. Most of all, I hope that you learned something great today. Hope you had some fun. Hope to see you again soon. Yeah, we'll see you in the next one. Cheers, guys.